Welcome back, boys and girls. We are still continuing with similarity. I'm just going to do quite a few examples just so that we are on the same page. Anyway, let's go straight to it. We are going to start with the first two similar triangles. They say in the diagram below, angle P is equals to angle U. Prove that triangle PRQ is similar to triangle URT. So basically we're proving this triangle is similar to this triangle. Okay guys, this is so easy. I'm looking forward to prove this with you guys. So remember, the order always help us. The order in which these letters are written, like triangle PRQ and triangle URT, is very important. It simply indicates that this angle, this letter here, the angle is equals to the angle there, like they've already indicated there. So they already gave us a cue. So it means that now we must just focus on angles because we're working with angles. Remember, there are two conditions of proving that triangles are similar. That will be corresponding angles are equal and corresponding sides are in proportion. Okay, so now we're gonna work on, let's focus on these angles. We've got angle P that we are already given is equals to angle U. And then what are we going to say? We are told, and then you write given. Okay, remember the order is very important. P is equals to U. So now we go into the second letter, R is equals to R. So it means angle R is equals to angle R. Wait, we've got two angle R's there. We've got angle R1, angle R2. So for you, you have to remember now. For you to know this, you have to remember the properties of lines. When two lines meet or intersect, at the intersection point, angles are formed. And we have got vertically opposite angles. So this angle here, it is equals to the angle there. And the angle here is equals to the angle there. And then when you cover this, you've got angles on a straight line. 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 And all around, there are angles around the point. They add up to 360. But now, our focal point, we're focusing on vertically opposite angles. If you can check, our angles here are vertically opposite. So angle R1 is equals to angle R2. Why? Because we've got vertically opposite, because they are vertically opposite angles. Don't you just love maths language? You don't have to rewrite the whole vertical opposite. So you just write vert op angles. How nice is that? So earlier we spoke about when two angles in a triangle are equal, the third angles in all triangles will be equal. So basically, angle Q will be equals to angle T. Is equals to angle T. And what are we saying? It is the third angle of a triangle. I'm so in love with the language. Third angle of triangles. So we are then concluding. Therefore, triangle PRQ is similar to triangle URT. Why? We've got three angles that are equal. You say angle, angle, angle. And therefore, we're talking about the proportionality of the corresponding side. We are going to say PR over UR. Therefore, PR over UR is equals to RQ over RT. RQ over RT is equals to PQ over UT. PQ over UT. And then you tell us they are similar triangles. Yeah, we've proved it. So, hamba no maporis. All right, before we get too excited, let us go to the next one. So we've got two similar triangles, and they say the diagram below, we've got triangle ABC, which is similar to triangle DEF. They're not saying we must prove it, they say we must determine the length of BC. So when they say we must determine the length of BC, you can see that BC is here. BC, the value of BC is x plus 40. So basically we need to find this x first so that we can add it to 40 and find the total length of BC. So since we know that we've got two conditions of similarity, it's either we work with proportion, whether we work with corresponding sides or we work with corresponding angles. So in this case, we are already guided. They want the length. So it means our focal point will be mainly on the lengths. So let's start with the statement of similar triangles. Remember, the order is very important, always helps you. So we've got AB over DE. AB over DE is equals to BC over EF. BC over EF is equals to AC. AC over DF. Over DF. And my reason will be similar triangles. I hope that it is visible there. Because of space, we might just have to squash our information on the small space. Okay, so now that you are done with this, the second step, you're going to basically substitute and you're going to target the sides that you are looking for. We are looking for BC. So you can either use this two or you can use those two. It does not matter really. But you have to be smart about it. You have to work with the ones that you know the values for. Does that make sense? So now let's check. AB. Do we have the value of AB? Yes, we have got 50. So it means this one can work. Do we have the value of DE? Yes, we have got the value of DE. So this one will work. Let's double check. We have the value of EF. EF, do you have the value of EF? EF. The value of EF there is X. Then it means we can work with this one. Because now with AC, we don't have the value of AC, we don't have the value of DF. So it will be very frustrating. So let's focus on this two. So the second step will be, my information is just going to be a little bit squashed. So I'm just going to write it in this small box. I'm going to say it's the second step. AB over DE is equals to BC over EF. Okay, now we check what is the value of AB. AB is 50, so we're writing 50. That is substitution. It's 15 centimeters, sorry about that. 15 centimeters divided by DE. DE is 5 centimeters. And BC, it is what we are looking for, but we have got the value of BC there. Do you see that? It is X plus 40. So basically on this step, I'm substituting. What is the value for EF? EF is X. Because of space, guys, unfortunately, I have to delete there on top, so that everybody can see. Okay, I'm just going to rewrite what I wrote there. I will say I written AB over DE is equals to BC over EF is equals to AC over DE. And then I'll say similar triangles. Okay, now like I've mentioned, you don't have to work with the 3 proportional sides. You can just target to work with the 2, but be guided by the information that you're given. Like for example, I know the value of AB, I know the value of DE, so it is easy to work. They are easy to work with. So I'm just going to say AB over DE is equals to BC over EF. Okay, AB, what is the value of AB? It is 15 centimeters. Remember, I am given. Divided by DE, I'm also given, which is 5 centimeters. It is equals to BC, I am given, it is X plus 14. And then EF, it is X. So from here, we are going to do the simplest step, the simplest method, which will be cross multiplication. Cross multiplication, guys, it shouldn't make you confused. You just say this denominator multiply by the numerator. So basically, it's cross multiply. So I'm going to say X multiply by 15 centimeters, which will be equals to this one multiplied by that. It's 5 centimeters. Okay, let us get rid of the centimeters first because they are going to cause a confusion. The centimeter cancels the centimeter. Okay, so now we're going to say we're left with 15 and 5. So we're cross multiplying. That's 5 into X plus 14. I cross multiplied. Remember, this 5 is multiplying the whole of that. That's why I put it in brackets. It's equals to X multiplied by 15. So when you cross multiply, you just this multiply by that and you keep the equal sign, and then it's going to be 15, 15x. Let it sink in. Are we all together there? Are you receiving it? Well done. So now this is distributive property. I believe that we all did distributive property. So we're going to say 5 multiplied by x and then 5 multiplied by 14, which will be 5x plus 5 multiplied by 14, it will be 70 is equals to 15x. And then from here, we are going to do additive inverse, or just group, additive inverse. So basically, I will leave the 70 this side, and it will, 70 is equals to 15x. And then if I do additive inverse, I simply mean that I add both sides with the same number. Okay, when I do additive inverse, let's do that. I will say 70 is equals to 50x minus 5x. Why? Because there's 5x this side, it is positive. So when it goes that side, it must be negative. Or I can just say minus 5x this side and minus 5x that side. So it's either you do it like that or you do it like this. Either way, this one will cancel that, and then I'll be left with 70, or I will just work with a simple way of doing it, group like terms. The 5x go and join the 15x that side. I hope it makes sense. And then now I have got 70 is equals to 15 minus that is going to give me 10x. So from here, I'm going to do, I'm going to divide both sides by 10 because I want the value of x. That is multiplicative inverse. So this one, divide this one. And therefore, the issue of space, but it's okay, we get in there. So this divided by that, this will be 10, and x will be, therefore, x is equals to 7. Okay, we are almost there. We just got the value of x, and remember, BC is equals to x plus 14. So now that we have got the value of x, then we are almost there. We don't have to panic. So we are going to substitute where we see the value, where we see x, we put the value, which is 7 plus 14 is equals to 21. 7 plus that is equals to therefore BC is equals to 21. Killed it. I hope that we all understand. I hope that we all understand. I do, and then I'm enjoying it. Okay? With all that said, I think we must then move on to other examples. I've written them on this side of the board. I hope they will be visible. I'm just going to let this sink in, and then we start with this one. Because of space, I'm going to have to cancel it. Oh, I'll cancel these diagrams. All right, so we have got triangle. We've got triangle ADE and triangle ABC. They are similar. Let's hear the question. They say examine triangles, those triangles there. After examining them, prove that triangle ABC is similar to triangle ADE. So I'm just going to write the order there. I love the order because it always helps us. So we are proving similarity of triangle ABC. Similar to triangle ADE. ADE. What other information are we given? We are given mainly the lengths. Okay? But that is not a problem. All right? So let us observe. Do you see that these two triangles are sharing A there? Because we've got triangle A, B, C. And then we still have A, D, E. That is our first observation. So A is common, okay? Which makes angle A to be equal to angle A simply because it is common. Now, before we can go any further, do you see that we have got parallel lines? Line DE is parallel to line BC. So now you have to remember the properties of parallel lines. When we have parallel lines, angles, and when we have parallel lines, and then they are intercepted, and then we've got a transversal line, or the line that intersect the parallel lines, then angles are formed. Okay, so if you can see that line BC and DF, they are somehow connected by BDA. Therefore, it means angles here are formed. Angles there are formed. So it means this angle here is equals to this angle here. Why? Because they are corresponding angles of parallel lines. All right, let's do that. Let's start. This and this. Angle A is equals to angle A. I've already indicated why. It is shared. It is common. So my reason will be angle A is common. Or I can just say common angle. And then I'm continuing. B and D. I've indicated that these two lines are parallel. And then we have got angles there. In grade 8, we used to say they form letter F. If I can highlight it. Do you see the F that is upside down? Or do you see this? So it means this angle and this angle are equal. So we've got angle B equals to angle D. Why? Corresponding angles of parallel lines. Corresponding angles of parallel lines. Which lines are parallel? BC is parallel to DE. So it's very important that you tell us that they are corresponding angles because of these lines are parallel. This notation that I wrote here indicate that lines are parallel. All right, and then CE, angle C is equals to angle E. Let's go and check it out. They still fall within the parallel lines DE and BC. So even if I can highlight it this side, you can see that a letter F is formed. It's like this. I hope that you see that. And then here is C, and then here is E. Here is E, and then here is C. So this angle and this angle are equal. And on this side, it's like this. It's like this. This angle and this angle, this is B, this is D. So this angle and this angle are equal. Hence I say letter F. It is just upside down. So the reason is still the same because they formed the same letter, which is going to be corresponding angles of parallel line BC and DE. Okay, therefore I will conclude or say therefore triangle ABC is similar to triangle ADE. Why? Angles. Got three angles that are equal. And then therefore I indicate that sides are in proportion. So I'll say AB over AD. Over AD is equals to BC over DE. BC over DE is equals to AC over AD. AC over AD. Similar triangles. Eyeball. It's going to be, sorry about that, AE. Didn't we kill it? And then we proved that this triangle and this big triangle are similar. So now we are moving on. There is a second question. That was the first question. They said prove that they are similar. So letter B, they are saying, hence determine the length of BC and AE. Ooh, not a big deal. Length of BC and AE and AE. Not a big deal. So we are just going to take it easy and focus. I'm gonna have to delete here, guys. Just so that we all see, I'm gonna write our letter. So they want the length, let me see the question properly, length BC and AE. Okay, let's do that. We're going to say the order AB over AD. AD is equals to BC over DE is equals to AC over AE. And then I just say similar triangles